Okay, good afternoon. My name is Mweneni. I'm standing in for Dr. Shiningayamwe for this presentation. Welcome to Natural Science and Health 6. This is supposed to prepare you for your August examination that is coming up. We'll use this but not cover all the content that is in the study guide because of the time. It will just highlight some important aspects and units that are covered in this module. The first one we'll look at is a chemical reaction. What is a chemical reaction? We can define a chemical reaction as a process in which one set of substances called reactants are converted to new substances which are called products. So we have reactants that in the end become products. How do we know when a chemical reaction have occurred? We can look at physical evidence like a color change. If there's a color change, we know it's a chemical reaction. Was there some solid formed within a clear solution? Is an evidence of a gas that is released? Is heat absorbed or released? If there is heat absorbed or released, if there is some evidence of gas being released, if there is some solid released, if there is some color change, then we know, according to these physical evidences, a chemical reaction have taken place. There are different types of chemical reactions. We have 4: a combination reaction, decomposition reaction, displacement reaction. And these are some of the examples of these 4. The synthesis reaction, 2 or more elements combine to make a complex substance. Like we have here the reactants, we have A and B combining to form a product that is AB. We have a decomposition where a compound breaks down into simpler substances. For example, here in the equation, AB breaks down to form A and B. We have a replacement and a double replacement. This I will not discuss in detail. Then we look at the symbols we use in chemical reaction. This is just a kind of a revision. We have these symbols that we are using. We use the S to identify that, to show that it's a solid state. AQ for something that has dissolved in water, for aqueous. L to show a liquid state, and G for a gaseous state. One thing that will be required to do is balance equations. And here are some guidance on balancing the equation. After you write the chemical equation, you have to balance it to make sure that the same number of atoms of each element are on each side. You have the same number of elements in the reactants as well as in the same number of elements in the products. Like here we have a reaction between lithium and water. This is water. Sorry for the formatting here, okay? Then we have here some steps that we can follow to balance the equation. First, you write the equation. We have lithium, which is in solid state, reacting with water, and it gives hydrogen gas and lithium hydroxide. Now we look lithium. We have 1 atom. Count the atoms. That's a second step. Count the atoms of the elements in the reactants. We have 1 atom of lithium, 2 atoms of hydrogen, and 1 atom of oxygen. Now we count the atoms of the elements in the products. We have 1 atom of lithium, 3 atoms of hydrogen, and 1 atom of oxygen. So we can see they are not the same. For lithium, they are the same. Oxygen, they are the same. But for hydrogen, we have 2 in the reactants, 3 in the products. So we have to change. We can only change the front, the coefficient in front. not any other part. Now we can put 2 in front. If we put 2 for lithium, then we have 2 for lithium. Then for oxygen, we have 2 also. For hydrogen, we have 2. Then we have on each side the same number. So if we look, we can change here. We were having 3 atoms of hydrogen. Then they need to be, we can make them 4. To make them 4, we can put 2 in front, then we have 2 hydrogen, and then we have 4 hydrogen on the reactants, and then we have 4 hydrogens on the reactant. For hydrogen gas, we have 2 plus the 1 in lithium hydroxide. There is also 2 hydrogen. We put the coefficient in front there, then they become 4. Write the coefficient in the lowest possible ratio, and then you must check your work. Then there is another example for balancing the equation. We have CH4, which is methane, plus oxygen, which becomes carbon dioxide and water. Then you count the numbers of carbon in the numbers of atoms in the reactants, as well as the numbers of atoms in the product. This example shows there is a total of 7 atoms in the reactants, but in the product, we have a total of 6. And we know 7 is not equal to 6. Where did the atom go? So we must balance the equation. And then this is how we can do it. The example is giving here. You can put a 2 in front of water. Then you have 4 hydrogen atoms and 2 hydrogen atoms. Now if you can count, we have 2 oxygen atoms plus 2 oxygen atoms, there are 4. Now here there will be 4 also in the products as well as in the reactants. Then our equation is balanced. Then our equation is balanced. So now in the end we have a total of 9 atoms in the reactants as well as 9 atoms in the product. So we must make sure, I urge you to work through the examples, especially if you are struggling with balancing the equation. Looking through the assignment, many people are struggling with balancing the equations, so these examples are trying to help you. Then we come also another examples here for you to balance the equations, and you must think, pair, and share. In order to be able to balance the equations, you must share the numbers equally among the products and among the reactants. Don't mess with the insides of the polyatomic ions. Put a square around them and label as X. Treat the whole as though it was an element. For example, these little numbers that's what I'm talking about, the ones that are in front, like for carbon 6, we have a 6 in front that is in small letters. You cannot mess with those numbers. You can only change the numbers in front, but not these ones, the polyatomic ions. Because changing those will change the product. Now we look at the rate of chemical reaction. For a chemical reaction to start, we need activation energy to start a reaction, because minimum energy is required. That energy is called activation energy. And the reaction rate, when we are talking of a rate is a change over time. The reaction rate refers to the speed at which chemical reactions take place over time. Reaction rate in some industries is important because the faster the rate, the less the cost. Some faster reactions can hurt industry. Example, ripening fruit. If you are selling tomatoes and they are ripening very fast, you might be able to make a loss, because then it will not last long in the shelves. Fruits, vegetables, we know they depend on their shelf life. So if the reaction rate, they ripen too fast, then it will make a loss. Then we look at the factors that determine the reaction rate. The first factor we'll look at is the temperature change rate. When the temperature can determine whether the reaction goes fast or slow. The temperature also affects the rate. Most chemical reactions speed up will increase in temperature because of faster moving molecules. Lowering the temperature usually slows down the reaction rate. Another factor that affects the reaction rate is the concentration. The concentration, the amount of substance present in certain volume is called the concentration of that substance. When you increase it, you increase also the reaction rate. When you decrease the concentration, you also decrease the reaction rate. Then we look at the surface area. Surface area also is one of the factors that are affecting the reaction rate. If you increase the surface area, you will increase its chance of reacting with other substances. For example, here you are given two practical examples. Twigs broken up compared to logs to begin a fire. If you begin a fire with a big log, that fire will not light up as fast as when you break down that rock and you start with small wood fires like twigs. Those ones will light up faster. Also, another example, a practical one. If you have a material and you crush it into small pieces. Let's say you have what? Let's say you are cooking meat. You chop up your meat into small fine pieces. It will cook faster. But if you are cooking a big piece of meat, it will take more time. So that reaction rate will not be as fast. The same using powder and using lamps is not the same. With powder, the reaction will be faster because you have increased the surface area. Then slowing down reactions. We have inhibitors. Inhibitors are those things that slow down the chemical reaction, makes the process of chemical change longer. Example, on cereal packets, the BHT slows down the spoilage of cereal and it increases the shelf life. And then we talk of inhibitors. If there are inhibitors, there are those that also can speed up the reaction. We have catalysts. Catalysts are substances that speed up the chemical reaction without taking part into the chemical reactions themselves. It produces the amount of product faster. Example, we have catalytic converters that are used in the cars to produce carbon dioxide and water, and is less harmful in cars fuel combustion. And then we have enzymes. Enzymes are catalysts that are large protein molecules that speed up reaction needed in cells to work properly. And here we have one example of an enzyme, proteases, which helps break down large protein molecules. And we see this, the meat tenderizers that we use is proteases. And it speeds up. We know if the meat is hard and you tenderize it, it will cook faster. And we have contact lenses. Cleaning solutions break down protein from your eyes that collect on your lenses and cloud your view. So these are two practical examples for one enzyme that. And then we talk of balancing equations. We have ionic equations. You'll be required to do ionic equations. Sometimes it involves oxidation reduction reactions, but here we just look at the equations themselves without going into redox reactions. The total ionic equation. Once you write the molecular equation, like synthesis, decomposition equations, you should check for reactants and products that are soluble or insoluble. We usually assume the reaction is in water. We can use a solubility table to tell us what compounds will dissolve in water. If a compound is soluble, and dissolves in water, then split the compounds into its component ions. If the compound is insoluble and does not dissolve in water, then it remains as a compound. Here is one's solubility table that you can use to determine whether the atoms are soluble or not soluble. And there are things that are not on solubility table. Gases, strong acids and bases dissolve in water, but they are not in the solubility table. Water slightly dissolves in water. Water is off. And then there are other tables and rules that cover more compounds than your table, but this is a basic table just to guide you. And then here is an example of an ionic equation. We have potassium chromate, which is soluble, and then lead nitrate, which is soluble, and they combine, and then they give an insoluble substances with potassium nitrate, which is soluble. And then you have to look at the total ionic equation that is given there, how you can break it down. And then we have the net ionic equation. On both sides of the equation, it's given there, and you can work out through this for you to be able to work out these ionic equations and not make mistakes. For ionic equations, the product at the end must be not having any charges, because the charges should balance. And then we have an example there. It's actually, the answer is in the previous one, silver nitrate with lead chloride in hot water. You can use the same example that was given previously to write the molecular, the ionic, and the net ionic. I thought I would come and work this out with you, but because of time, we won't have enough time to work through that. And then we go to organic chemistry. Organic chemistry is the chemistry of carbon compound. Inorganic chemistry is the chemistry of compounds of all elements other than carbon. The general properties of carbon are listed there. Most carbons are non-electrolytes, so organic chemistry talks of carbon compounds. And then for this one, we have a bonding arrangement, because then this bonding arrangement will determine the properties of particles that are being formed. We have there the number of valence electrons. For carbon is 4, for hydrogen is 1, for oxygen is 6, and so on. Then the total number of bonds to form a neutral atom. For carbon is 4, 1, 2, and 3, for oxygen and nitrogen. And then the number of single bonds. These are very important, especially for carbonic compounds. Number of single bonds that can be formed, number of double bonds that can be formed, number of triple bonds that can be formed, and the total bonds. This will help you, especially when you are trying to draw molecular and structural bonds, compounds. Then we have here hydrocarbons. We have 4 types of hydrocarbons. We have alkanes, which contain only single bonds and have a generic formula of CnH2n plus 2. Then we have alkenes, which contain a double bond. We have alkynes, which contain a triple bond. And we have aromatics, which are like ring structures with alternating single and double bonds. Then we have unsaturated hydrocarbons. Unsaturated hydrocarbons have double or triple carbon-carbon bonds and are more reactive than saturated carbon compounds, which have only single carbon-carbon bonds like alkanes. The unsaturated hydrocarbons, we have alkenes, which contain carbon and hydrogen atoms and single and double atoms. The simplest alkene are ethene and propene, and then they are named in the same way as alkanes, with the suffix "in" replacing the "ane" in alkenes. They have the same number of carbons, and then it's only the end, the suffix that changed. The location of the double bond is indicated by the number, and then we have geometric isomers sometimes. Then we look at alkynes. Alkynes are also unsaturated hydrocarbons which have triple bonds. One simple alkene is ethane, which is a reactive. And then we have acetylene. And then they are also named the same way as alkenes and alkanes. Now that's the end for hydrocarbons. We go to study hints for the examination. This subject requires memorization of facts. You need to memorize. You need to know some of the basic facts by heart. Like the ones that we were just discussing now, alkanes, alkenes, alkynes. The suffixes you need to know, the prefixes you need to know them. Whenever you are reading the textbook or taking notes, especially when you are studying for your examination, or write down and highlight unfamiliar terms and review these terms frequently. You can create flashcards. Maybe you have one for alkenes, alkynes, alkanes, and you can use this to test yourself regularly and compare, or maybe you want to know which ones have triple bonds, double bonds, and so on. Or you want to remember which ones are soluble, which ones are not soluble, also for solving reaction rates, for solving balancing of equation. Learn important prefixes and suffixes. You'll quickly be able to identify and diagram compound once you learn characteristics groups such as amine, OH, hydroxyl, and hydroxy. Develop mnemonics to help you remember. For example, about.com, give the following mnemonics for the first 9 elements of the periodic table, because you need to know this periodic table. You need to be able to remember which ones are transition elements, which ones are the first ones, which one are the what group. The first 9 elements of the periodic table are given by these mnemonics. Happy Henry likes beer, but could not obtain food. So you have hydrogen, helium, lithium, barium, boron, carbon, nitrogen, oxygen, and fluoride covered. So you'll be able to, even when you are drawing your covalent bonds and so on, you'll be able to tell, okay, these ones are the first 9, they are in the first group, they are in the first period, and so on. So I wish you all the best for your examination. This is just to highlight some of the things that were not covered in this presentation, but might be helpful for you to prepare for your examination this coming August. The chemical reactions we have looked at and discussed, especially the rate of chemical reactions. There is something that we did not in this presentation look at, that is calculating the moles, stoichiometry, especially the volume of gases, the properties of metals and their properties. Organic compound we briefly touched, but you need to know the functional group, how to draw the structures, their molecular structures, and so on, their diagrams. You need to know how to balance equations very well. This I have given you several examples. It's what we were concentrating on now. The ionic equations you need to know, and there is also a part on industrial uses, fertilizers and ammonias. That part you need to look at also when you are preparing for your examination.